Um, so, how did you enjoy it on a holiday in the middle of the week? It's all right, eh? Yeah, Carter, you're hurting me. I enjoy seeing you here every day, and then you say something like that.
Well, you saw me yesterday still.
Oh yeah, that's true. Yeah. Okay, so today we're going to look at adding vectors by Pythagoras. I'm going to do a quick short review that you don't have to write down or anything, just sort of remind you of what you already know. We did the pirate treasure thing the other day there, and of course all the winners got free candy, right? Yeah. Sorry, you want to hear? Yeah, I know, I'm just teasing you. I didn't give up candy. Okay, so what is a vector? A vector is a quantity which has both magnitude and direction. Examples of vectors include displacement, velocity, acceleration, and force. To fully describe one of these vector quantities, it's necessary to tell both the magnitude and the direction. What do I mean when I say magnitude? The size, exactly. So, like, give me a pirate treasure map vector, Carter. Like, that's just an example one that you might have drawn the other day there. 8 paces and a direction. Just make it up.
North 40.
Sure. North 40 south. Would that work? Well,
But it's either way.
actually, no. Yeah, it's either way, so that wouldn't work, right? North 40, you'd have to say like east or west, right? Okay. So which one of those is the magnitude? The 8, and of course, north 40 east is the direction. North 40 east would be like north, and then I go 40 degrees towards east, right? Yes? Yes, I get that, Mr. Manning. Excellent. Okay. There's 3 types of direction notation. 30 degrees south of west. This is generally the most hated one I've found over my many years. People don't like it. South of west means look west and then go 30 degrees south of west. West 30 south, is that the same thing?
No.
Look west, go 30 degrees towards south. Look west, go 30 degrees towards south. They are the same. 240. Look, it says right there, all mean the same thing. Right? 240, we've got 0 at top, 90 is east, 180 is there, so 240 is going to be like right about there, which is the same as that one. Right? And pilots use this varying method that has north at 0, directions rotating clockwise. Okay, and there's a website there if you were to look it up or what have you. So that's kind of where we've got so far, right? Quick review. Yeah, all good? Okay, so now let's talk about adding vectors. Okay, today we're just going to add by Pythagoras method. You probably have heard of Pythagoras before, you know, a squared plus b squared equals c squared. Does it matter what letters you use here? Should be x, y, z. Some books put the c squared. It's like a equals b plus c squared, that kind of thing, right? It doesn't matter. As long as the long one is what? By itself. And did you ever get shown this proof in math class? Something like that? I'm not seeing a lot of yes, so no, eh? Okay. Pythagoras. Okay. This is what you have on that sheet, so just follow along with me. Most of us are accustomed to the following form of mathematics. If I said 6 plus 8, hopefully all of you would say 14.
10.
But 6 plus 8 could also be 10, it could be 2, or it could be 5. Okay? When you become students of physics and approach the task of adding vector quantities, we soon become aware of the fact that the addition of 2 vector quantities with magnitudes 6 and 8 will not necessarily result in an answer 14. It might. The rules for adding vector quantities are different from the rules for adding 2 quantities arithmetic. In other words, regular old math. 6 plus 8 will not necessarily be equal to 14 because you have to account for the, starts with a D, direction. You have to account for the direction. And you'll remember when you guys did the pirate treasure map, right? You accounted for the direction. You had the protractors out. Vectors are quantities that include a direction. As such, the addition of 2 or more vectors must take into account that the quantities being added have a directional characteristic. There are a number of methods for carrying out the addition of 2 or more vectors. In grade 11, we deal mostly with scale pictorial representations. When you get to grade 12, we start to deal with components. Students find this particularly easy I think it's because they complain, why didn't you show us this in grade 11? I think they find it easy because I explained it this way in grade 11. So, don't complain. The most common method is the head to tail, or I often say tip to tail. And each and every group did it without me telling you to do it the other day. Okay, tip to tail method of vector addition. Using such a method, the first vector is drawn to scale in the appropriate direction. The second vector is then drawn such that its tail is positioned at the head of the first vector. Do you have that picture? You do not. Please draw it in there. Josh has it now, because he drew it ahead, right? So we've taken these two vectors, and we've added them tip to tail. Okay? Right here, Lee.
We're not supposed to learn anymore.
We're not supposed to learn anymore.
No, in the morning.
What?
Not those things.
Now, oddly enough, even after everyone did it exactly the correct way on the pirate treasure thing, got it right away. Okay? They still struggle when I give them regular vectors. So if you ever ask me the question, do I put these tip to tail, just think back to the pirate thing, and oh yeah, that's how we did it, right? And he didn't even have to tell us how to do it. The sum of two such vectors is then represented by a third vector which stretches from the tail of the first to the head of the second. And let's just underline that, or highlight it, or whatever you got. Okay? Where is it? The tail, oops. Tail of the first to the head of the second. The third vector is known as the resultant. The answer to a vector addition question is called the resultant. Okay, the answer to an arithmetic question, 6 plus 8, what's that answer called? The sum, exactly.
You have the Greek and Latin.
I don't think so. I think I returned it to you, I think.
It might be like it.
Yeah. Yeah. I think so. Okay, so when the question says find the resultant, it means add the vectors and tell me what the answer is. Okay? The resultant is the vector sum of the two individual vectors. Of course, the actual magnitude and direction of the resultant is dependent upon the direction which the two individual vectors have. Okay, so this red one right here is called the resultant. How do I find out the number? How do I do that? Like how would we have drawn these black ones? With a ruler and a protractor. So how am I going to find how long the red one is? With a ruler. Okay? When I click on this link, I get this. Okay? So I'm going to grab a vector, and there's another one. Yeah. And I'm just going to sort of like, do whatever, like this, right? Where's the resultant? Okay, it's from where you start to where you end. Now, here's the common mistake that everyone always makes. They want to do this. They draw this one, then they draw this one, and then they go from there, they go back to where they started. That is wrong. Okay? And they say to me, Mr. Bennett, I thought it was supposed to be tip to tail. And they say, well, this one here, okay, go away. This one here isn't tip to tail. Sorry, no, the green one there. I did that wrong. The green one isn't tip to tail. Well, the green one's not supposed to be tip to tail. Like, see how it's tip to tip like that? Right there? It's not supposed to be. This is the tip to tail. The ones you add together are tip to tail, and then the result is from where you started to where you ended. Think of it as like a shortcut. If you were walking on these streets, if I told you to walk 1, 2, 3, 4, 5, 6 blocks east and 1, 2 blocks north, you would end up right there. Okay? Have you ever heard the term as the crow flies? Because apparently crows only fly in straight lines. I don't know. How would the crow fly? From there to there. They wouldn't walk the blocks. Crows don't walk, they fly. Okay?
They have feet.
They do have feet.
I've seen them walk.
You've seen crows walk. You're going to be a thorn in my side there, Carter. Okay. So this principle of head to tail addition of vectors is illustrated in the animation below. Obviously, you do not have the animation on your paper. In each frame of the animation, a vector, just look at it up here. In each frame of the animation, a vector with a magnitude of 6 in green is added to a vector with a magnitude of 8 in blue. The resultant is depicted by the black vector, which stretches from the tail of the first to the head of the second. So you'll notice that as the green vector sort of goes around, as it is animated, the black vector becomes a different length, right? Let's just let it start all the way around here. So when it's right, green is like this, the answer is 14. Now the answer is 13.5, 12.2, and see how the black vector gets smaller? Because once the green vector starts moving, you have to account for that direction. Now, there's a mistake in the animation. Can anyone see it? Spot it. Trevor? Well, that's not really a mistake. I'm going to tell you. It's actually on the screen already. What's the direction of the blue vector? 0. Where is 0 supposed to be in the physics world? North. Right? Straight up and down. Math person made this so it has east at 0 degrees. Bad math people. Apologies to the math teachers. As can be seen from this animation, 8 plus 6 can be equal to 14, but only if the two vectors are directed in the same direction. Physics people and math people have a fancy word for same direction. It's called collinear. I will never use that word. Okay? It's just a fancy math professor word. Collinear means in the same line. Right? They share the same line. All that can be said for certain is that 8 plus 6 can add to a vector with a maximum of 14, and the minimum is 2. When is the minimum 2? When it's 8 this way and then 6 the other way. Right? Notice that it's always tip to tail. Am I making sense? Yes? Okay, you're going to get a chance to do some stuff real soon here, because you've been doing lots of listing so far. The resultant vector, which is the summative result of the addition of the given vectors, is drawn from the tail of the first to the head of the second. And the magnitude and direction of the result is determined using a protractor, ruler, and the indicated scale. So if I'm adding the two black ones, how do I find the red one? Use my ruler. What do you guys have to draw here? It's actually on the next page by now. Okay? So a lot of kids, believe it or not, kids say to me, how do I find that answer? Use your ruler. Just measure it. Just measure it. Okay? Use your protractor. Now, where do you put the protractor in the ruler? Well, the length of it doesn't matter whether you start from this end or this end, right? Like you can measure from either end. But where do you put the protractor? Do you put it at the start or do you put it at the end? Start. Always. And I see kids make this mistake quite a bit, unfortunately, right? But if I'm telling you to walk a certain direction, don't you want to know that direction before you want to start walking? Right? If I say go walk 10 miles, and I'll tell you what direction to go once you get there, well, you're going to be lost. Right? It's got to be from the start. Now, you already know the answer to this. Let's hope you remember. The question often arises to the importance of the order in which the vectors are at. I still get kids say to me, does it matter what order I do them in, Mr. Bennett? For instance, if 3 vectors are to be added, calling them A, B, and C, will a different result be obtained if a different order of addition is used? Will A plus B plus C be the same as C plus B plus A or B plus A plus C? Does the order matter? No. We learned that in the pirate thing. Let's just watch, because I spent some time making this cool little video. A plus B plus C. There's the result. Now let's do C plus B plus A. Where's the result? From the start to the finish. B, say, no, plus C. Oh, I did it the wrong way, didn't I? Same result? Same result. It doesn't matter what order. Doesn't matter how many vectors you add. How many vectors were in the pirate treasure thing? Like 6? Right? And there's a few. Sam, your group was like a little close, right? As long as you don't make mistakes. And then we talked about accumulated errors too, and we talked about like major errors as well. Order doesn't matter. If you learn anything today, order doesn't matter. you want to draw that on your page? I'll pause here for a second if some of you want to draw it. I think there's room at the bottom of page 2. I'm going to go do attendance. Okay, so if you ask me the question, does order matter? I'm probably going to give you this look. What does it mean? It means I've already told you that. You should know. Okay, I'll still help you, but I might give you a frown. Okay, now let's move this from the abstract to more like sort of application kind of thing. Okay, I haven't actually showed you how to do the adding yet. We're going to get to that. Okay, Matt, did you get the handout? Are you going to ask for it?
Yeah.
Observe the 3 planes in the picture below. Each plane is heading south with a speed of 100 kilometers an hour. Each plane flies amidst a wind which is blowing at 20 kilometers an hour. In the first case, the plane encounters a tailwind which is from behind of 20. The combined effect of the tailwind and the plane speed provide a resultant velocity of 120 kilometers an hour. Because of the wind, the plane actually travels 120. Right? Which one of the vectors is the plane speed? What color? Blue. And the red one is the wind, right? In the second case, the plane encounters a headwind from the front of 20 kilometers an hour. The combined effect of the headwind and the plane speed provide a resultant velocity of 80 kilometers an hour. How'd they get 80? 100 minus 20. Right? These vectors here, are they drawn properly? What's wrong? Not drawn tip to tail. So I would suggest, if you can, draw something like that in there. Okay, in the third case, the plane encounters a crosswind from the side of 20 kilometers an hour. The combined effect of the headwind and the plane speed provide a resultant velocity of a weird number, 102 kilometers an hour, directed at an angle of 11.3 degrees angle east of south. Have they drawn it properly? They have not. It should be like that, tip to tail. What's that black vector called? The resultant. What letter do you think we use for result?
R.
R, which fits in nicely with Talk Like a Pirate Day. Josh? What's the pirate's favorite letter? Oh, Josh, you're killing me, man. These 3 resultant velocities can be determined using simple rules of vector addition. In the case of the crosswind, the Pythagorean theorem, and SOHCAHTOA. Did everyone learn it in grade 10? SOHCAHTOA?
Isn't that like the lady that wanted
Yeah, I was
Lewis
gonna say
and
the
Clark?
native lady.
The what?
Yeah, the native lady that wanted Lewis and Clark.
No. I don't know who that is.
Haven't you watched American Museum?
No. No. Who? Do you guys know what SOHCAHTOA stands for? Actually, you know what? I found out that maybe this isn't being taught, so maybe this might help you. Joel, help us out. SOH? Well, sine is O over H. Opposite over hypotenuse. CAH is cosine or adjacent over hypotenuse. And TOA is tangent, which is opposite over adjacent. Okay? So if you weren't taught SOHCAHTOA and you still have problems remembering those, well, there's a little trick to help you. SOHCAHTOA. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tangent is opposite over adjacent. Remember, I'm going to post all this up online too, right? So it's all going to be there as well. Okay, so let's get right to adding vectors by Pythagoras. You have it on the next page. I, for some silly reason, have it in a second folder or second document. You're going to need a calculator. Okay, we start with the most basic. Students always have difficulty because it's one of those, you know those math questions where the first one is so easy that it's hard? It's kind of one of those things. Never heard of that? When two vectors are in the same direction or collinear, it's easier to add them. place them head to tail and simply measure the total length. Or just add the two magnitudes together. Here's a little animation to describe it. Here I've got vector 8, here I've got vector 6, and I'm going to put them tip to tail, and here comes the resultant. It goes from where you started. Whoa, what's going on there? It's 3D if you got like the glasses on, it like comes out at you. Yeah. So I got 8 plus 6 is a vector of 14, from where I started to where I ended. Does that make sense? Pretty easy. I'm never going to ask you to do that, actually. Okay, does the order matter? I'll show you again. There's 8, there's 6 plus 8. Ooh, what's it going to be? Surprise, surprise, it's 14. Does the order matter? No, the order doesn't matter. Now, what if the vectors are not on the same line? What if they don't point in the same direction? How do you add them? Okay? What if I've got, I'll do them in black. What if I've got 8 and 6? The rule is place the vectors tip to tail and measure the result, just like this. There's 8, there's 6. Result is from where you start to where you end. Is it going to be 14? No. How do I find out how long it is? Could use a ruler, but because these vectors are at a right angle, right? They're perpendicular. We can use our old friend Pythagoras. He's really old. He's dead. So how would I do that here? What's the rule? How do I solve it? Who remembers Pythagoras? Let me see. Do I need to go to the next page? The resultant vector can be measured or calculated algebraically if the vectors are perpendicular. Now, I cannot stress this enough. See how it's in bold and it's italics and it's underlined? And I'm going to circle it. And I'm also going to get my highlighter. And I'm going to do this. And I'm also going to go into there. And I'm going to do this. Okay. I can't stress this enough. How many times I've had to mark something wrong on kids' papers because they do this. They've got vectors. They got 8 and they got 6 like that. And then they tell me 8 and 6, they go 8 squared plus 6 squared. What's wrong with that? They're not 90 degrees. And I get so tired of writing on papers, not a right triangle. I should get a stamp. Because I do it year after year after year after year. They must be perpendicular for you to do that. And even after I've stamped my feet and highlighted and circled and made a big rant like this, there's still 5 people in this room that are going to do it to me. Probably harder. Don't do that to me. I want you to practice here. Oh, actually, let's go back. I don't think we finished. You know why? What didn't I not finish here? I didn't actually give an answer, did I? Let's do the answer. Okay, so how are you going to write this out? Do you guys have space to write it out? Good. Okay, I'm going to label this R. And then you're going to write R squared is equal to 8 squared plus 6 squared. Is the resultant always going to be the one by itself? Most of the time. R squared equals 8 squared is 64. 6 squared is 36. R squared is 100. R is the square root of 100. R is 10. Did I show too much work? Probably. If you want to write every step, you go right ahead. I got no problem with that. I only show every step there just so that everyone understands. What I would normally do is I would write R squared equals 8 squared plus 6 squared, and then I would just write R equals square root of 100. Okay, I sort of combine a couple steps there, and then do my answer. In grade 12, I sort of let kids just do that because by then everyone just knows how to do Pythagoras. It just should be a given. Okay? Am I done?
Yeah.
Usually when teachers say, am I done? The usual answer is no. Why am I not done, Martin? Do you know? What am I missing? What am I missing? Anyone? Stop it, what am I missing?
Oh.
No? Come on, what's a vector? It's got to have a magnitude and a direction. I don't have a direction. What funny symbol do we use for direction? The Greek letter theta. The Greek letter theta. Now, no you don't. Theta is the angle here. Okay, which one of the sine, cos, and tan should I use? Well, what sides do I have? Martin, I have this one and this one. Which ones are those? I have opposite and I have adjacent, right? So you're going to write tan theta is equal to, do we need to write opposite over adjacent? I don't think so. We're all big boys and girls. We'll just write the opposite side, which in this case is 6, and the adjacent side, which is 8. Now, do you remember how to solve this? And I know for a fact this is taught in grade 10.
Yes. Use your calculator.
You'll use your calculator. And I'm not sure how your teacher writes it. This is how I write it. I write theta equals tan to the minus 1, which means second function tan, right? Go ahead, find me an answer, and then I'll confirm it for you in about 20 seconds. Do you remember how to do it on your calculator? It's been a while, I'm sure. Now, there's two types of calculators. There's the kind that you go 6 divided by 8 equals second function tan, and there's the kind of calculator where you go second function tan, bracket, 6 divided by 8, bracket, and then 8 equals, right? You need a calculator? Oh, one decimal place, good. So the answer is, let me just do it here. I always forget which calculator this one is. 6 divided by 8, and then... Whoa, what's going on? One decimal place is just fine. Everyone's got a different kind of calculator. I get an answer of 36.9. Am I done now? Or are you just saying that because I said earlier when the teacher asks if the answer is am I done, the answer is always no? Or you really do know? You think I am done now? You're wrong. There's still one more test. Set you up.
How do you get that number?
I'm going to help you again with the calculators in a second, okay? 36.9, I need the east and the west and all that stuff, Josh. Okay? So this is going to be now, which letter comes first? Starting here, do I go north, east, south, or west?
North of east.
You could say north of east. You could also say
East.
And I'm going to round that up to no decimal place. I'm going to say east 37 north. East 37 north. Or if you prefer, 37 east of north. Okay? When we get to the practice part, I'll come around and help individual people with the calculator. Okay? Just so that people aren't sort of waiting. Okay? As a rule of thumb, yeah, one decimal place. I don't care. If you wrote 36.9 or 37, no problem. 100% right. The words is what important. Pilots actually always round to the nearest 10. Because when they're flying a plane, the difference between 0.1 degree and, or the difference of 0.1 degree means nothing. Absolutely nothing. Right? Unless you're flying from like here to like Australia, it ain't going to make any difference. And you know what? When you fly over to Australia, they change course many times anyway, so it doesn't matter. Okay? It's only academics and professors that worry about stuff like that. Okay. go ahead. I think you've got a practice question, right? Right there? Am I right? Okay, so go ahead and try that, and I'll zip around and I'll help people with calculator problems. Okay, so, is this the right one? No, it's not. This one. Okay, man walks 3 kilometers north, then 1.5 east. What is his resultant displacement? Now, does the order matter? It does not. But generally, people will draw it in the order that it's given, right? So 3 kilometers north is going to be, right? And then 1.5 east. Okay, so many of you drew it that way. What if you drew it this way? What if you went like this and then like that? No problem, 100%. You just put it in a different order. No big deal. Okay, so the resultant displacement is like this. Go ahead, Connor. So the first step is to find the magnitude. So it's going to be r squared is equal to 3 squared plus 1.5 squared. Does it matter whether you put the 3 or the 1.5 in first here?
Yes.
Doesn't matter. R is 9 plus 1.5 squared is, I think, 2.25. I don't know what the answer is here. What's the answer, Zach? Don't know? Come on. No, I know I could do that. I meant the square root part. 3.35. So we'll say 3.4, and I guess that's kilometers, right? Okay, so Leighton, that's the first thing you do, right? This is the size, this is the magnitude part of the question, right? Would it matter if you draw it this way? You're going to get exactly the same thing, 1.5 squared plus 3 squared, same thing, right? I had a few people ask me, like, where do I draw the theta? Always draw the theta where? Where you start. Again, common mistake. Don't make that mistake. It's where you start. It's not there. You got to know what direction you're going in life before you head out. Okay, so the theta is there. I like to write tan theta is equal to, I would actually do this. You know what? I'll show you how I really do it, because I'm kind of lazy and like shortcuts. I would just write theta equals inverse tan. I know that I have to do inverse tan. Every one of them is going to be like that. Right? Just start with that. Theta equals inverse tan. Here's the problem, right? What do I put first? Which one's opposite? Opposite the theta is the 1.5. It's opposite. It's opposite the angle. So 1.5 over 3. This one mine, Zach, or is it yours?
That's mine.
What did you get?
26, we'll say 27?
I just got 26.
26.6? Yeah.
I did the exact same thing as that. I got all decimals. I did it multiple times.
You might be in radians on your calculator. Means your calculator is measuring units in radians instead of degrees. It should be in DEG. Sean, is he in radians? No? I'll come back and have a look. So what would be the letters that go with this? I'm getting close to done, you guys. Which one, north, east, south, or west, is it start off at? It starts off north, right? So it's going to be north. And then I went 27 east. North, 27 towards east. And I'm going to do one last one here. What if you drew it this way? Well, here's what happens. Watch real close here, you guys. Really close. Here, what did I just do? Here, you're going to have theta equals inverse tan. Now, opposite over adjacent. Now, opposite is 3. Am I going to get the same number? I am not. I'm not going to get the same number. In fact, I'm going to get 63. Did I do it wrong? No. It's not north 27 east. It's now east 63 north. And are those two equivalent? Yes, they are. They are the same thing. I will accept either answer. Okay? On my answer key, I always have both because kids always do it. There's always one or two that do it the other way. Okay? It doesn't matter. I'll take either one. How do you know? Maybe if I've given you questions to do and you look in the back and your answer is different, how do you know it's the same? What? Subtract from what? You're right. Go ahead. Yes, you do. I know you do. You wouldn't say subtract if you didn't know. Come on. No, not those two actually. No. I thought you had it. Subtract from 90. Right? These numbers have to add up to 90. Right? Joel. Yeah. Okay. If you haven't done so, do the next practice one. I'll do the answer right away. And then I think there's two more sort of extra ones there as well, right? Take some time, practice, make sure you know what you're doing.